Hello again, this is Ron, FT02, and you're doing the Foundation Theory course. This tutorial is going to be on basic electricity. For your foundation, you need to have an understanding of some basic electrical terms such as charge, voltage, current, resistance, and power. And we're going to cover those subjects lightly in this tutorial. The slide on the screen is an atom. There are 100 plus different types of atoms on Earth. Metals, iron, copper, tin, silver, gold, they're all atoms, and all metals are conductors of electricity. And things like glass, rubber, plastic, ceramic are insulators of electricity. The things that we're interested in about the atom are the electrons. And the reason why we're interested in the electrons is because it's possible to remove electrons from an atom. And when we remove electrons from an atom, we create what is called charge. And the movement of charge is what electricity really is. You've actually probably done this yourself, removed electrons from a material and created charge. Have you ever done this experiment? Run a comb through your hair several times. Tear up some small pieces of paper first, run the comb through your hair, and then move the comb close to the pieces of paper on the table, and the pieces of paper will leap off the table and attach to the comb. What's happened is you've used friction to remove electrons from the comb, and the comb is now charged, would be a positive charge, electrons are a negative charge, and unlike charges attract, so when you bring the comb to the paper, paper will leap off the table and stick to the comb. Now, the movement of the paper from the table to the comb is a movement of charge, and that's what electric current is. How quickly we rub the comb in our hair will determine the amount of charge. So with a higher charge, we'll have a quicker movement of the paper from the table to the comb. So the movement of charge is electric current. And for our purposes, we will say that electric current is the movement of electrons. You can get currents using other things other than electrons, but we're just going to stick to electrons, and 99.9% of the time it is electrons that are doing the moving in electricity. When you do use friction to remove electrons from the comb, the electrons are negative and the comb is positive, and that's what attracts the paper to the comb, because the negative electrons in the paper are attracted to the positive charge on the comb. Now there must be some force acting between the comb and the paper to pull the paper to the comb. That force is called voltage or electrical pressure, and it's measured in volts. The action of the paper moving from the table to the comb, that's a movement of charge, and so that is an electric current. And the electric current is measured in amperes, voltage is measured in volts, we'll talk more about that soon. The paper has some weight and therefore has some resistance to being moved, and that is electrical resistance. So just with a simple comb experiment, you've demonstrated three primary properties of basic electricity, and that is current, voltage, and resistance. Voltage, or electrical pressure, is the force acting between the comb and the paper. The movement of the negatively charged paper to the comb is electric current, and the effort that must be overcome to lift the paper from the table to the comb is resistance, and that's measured in ohms. Now we don't use friction and a comb to create imbalanced charge. That is to strip negative electrons off the comb and create an imbalanced charge. The normal method is to use a generator or a battery. A battery chemically strips electrons from one of the terminals in the battery. But whatever means we use is not important here. What's important is that we can create in one spot more electrons than there are in another spot. The spot where there are electrons we call negative. The spot that is missing electrons we call positive. And if we have that situation and we put a conductor of electricity between those two squares, electrons will flow from here through the conductor to the least negative place or positive place until the electrons are balanced out. The pressure that exists between the negative and the positive is called voltage, and it's measured in volts. The flow of electrons from the negative to the positive is called current, electric current, and it's measured in amperes. And amperes is often just abbreviated amps. And the resistance that the material has to the flow of electrons is called resistance. And it's measured in ohms. And we'll be talking more about that soon. Just to reinforce what we just covered, I've drawn it a little bit more symbolically. Here we have a material which is negative. Here we have a material which is positive. That means it's lacking electrons. This one has an excess of electrons. And if we put a conductor between them, the two, electrons will flow from the negative one to the positive one. The pressure that exists between the two is called voltage. The flow of electrons between the two is called resistance. And the opposition to that flow by the atoms in the metal is called resistance. Voltage is measured in volts, current is measured in amps or amperes, and resistance is measured in ohms. Now, if you're having a little bit of trouble visualizing that, visualize this instead. Imagine you had a tank of water, a very large tank of water, and a small tank, and you connected them together with a pipe. Then water would flow from the tank with the excess water, that's like being negative, through the pipe to the tank with the deficiency of water, that would be positive. This water example is exactly the same as electricity. The moving here is being done by water. The moving in electricity is done by electrons. The air pressure is making the movement possible. In electricity, it's electrical pressure or voltage which makes the movement possible. The size of the pipe can restrict the flow of water. The resistance of the conductor can restrict the flow of current. All metals are good conductors. Things like rubber, plastic, ceramic, glass are very good insulators. Okay, it's time we talked about current and voltage and resistance a little bit deeper. A chap by the name of George Simon Owen worked out the relationship between current, voltage and resistance in an electrical circuit, and he came up with this equation. We're not going to discuss Ohm's law in detail, we're just going to be discussing the Ohm's law equation. And what Ohm found, that if you wanted to calculate current, you could find it by dividing the voltage by the resistance. So for example, if you had 10 volts and 2 ohms, 2 into 10, the current is 5 amperes. So if you know the voltage and resistance, you can calculate the current. If you want to calculate resistance or voltage, you can transpose this equation for resistance or voltage. And if you know how to transpose formulas, you can do that. But for the foundation, this is all you really need to do to remember Ohm's law, and that's use this triangle. So if you're trying to find, for example, current, remember this triangle, draw it, and put your finger over what you're trying to find. You're trying to find current. I equals E divided by R. I equals E divided by R. I equals E divided by R. Put the finger on what you want, and then say I equals E divided by R. When something is written above something, it means divide. When two things are written side by side, it means multiply. So if we wanted the formula for resistance, and you'll need to know this for your foundation assessment, it's about the only math you will need to know, or a little bit more. If you wanted to find resistance, put your finger on resistance. R equals E divided by I. R equals E divided by I. If you want to know voltage, put your finger on voltage. E equals I multiplied by R. As easy as that. And we don't need to go into Ohm's law at a greater depth for this course. And let us do some mathematical examples using this equation. Just remember that current is electrical flow, the flow of charge or electrons, measured in amperes. E is electrical pressure or voltage, measured in volts. R is electrical resistance, measured in ohms. And for your foundation assessment, you will have to do some simple calculations using this equation, and you could be asked to find I, E, or R. So that's why you need the Ohm's law triangle. Let's do some examples on the types of calculations you might be required to do in your foundation assessment on Ohm's law. And this is probably the most mathematical the foundation assessment gets. Here we're wanting to find out current. And we know the formula for current from the triangle, I equals E divided by R. And I've rewritten that again, I equals E divided by R. That slash means divide by. And we're being told that the voltage is 20 volts and the resistance is 5 ohms. What is the current in amperes? So I equals E over R, that means I equals 20 divided by 5. I equals 20 volts divided by 5 ohms gives us 4 amperes. You won't have to do any complicated calculations with decimal points and things like that. And if you're a little bit rusty with simple arithmetic, you can use a calculator. But most of the calculations are going to be easy, like 2 into 20 or 5 into 20 or 6 into 30, things like that. But if you're unsure, use a calculator. Use the Windows calculator, or you can't take that into the assessment, but you can take an ordinary calculator into the assessment to help you do that, if that makes you feel better. Okay, let's look at another one. Now we're being asked to calculate resistance, and we're being given voltage and current. We're told that E, the voltage is 120 volts, E is 120 volts. We're told that the current I is 5 amperes. I is 5 amperes. The formula, put your finger over the R equals E divided by R. Oh, sorry, I. R equals E divided by I. R equals E divided by I. So just put the values in your equation. R equals, E is 120, I is 5. 5 into 120 goes 24. And if you're not sure, use a calculator. 120 divided by 5 equals 24 ohms. So if you've got 120 volts and 5 amperes, the resistance of the circuit is 24 ohms. It's not too hard, is it? In this Ohm's law problem, we're being asked to calculate voltage, and we're being given I, the current of 3 amperes, and E, the voltage of 90 volts. We want the equation for voltage. Put our finger on the E. E equals I multiplied by R. E equals I multiplied by R. When you don't have a multiply sign between two characters written side by side, it means multiply just the same. So if we put our values in the equation then, E equals 3 amperes multiplied by 90 volts, which is 270 volts. And now you've seen the three possible combinations and the degree of difficulty as far as the numbers are concerned of what you can expect in terms of Ohm's law calculations in your foundation assessment. There is one other calculation you may have to do, and that's the calculation of power, P. Now, we're all used to power. If you go and buy a light bulb, you buy a certain wattage. You buy a 30 watt bulb or a 5 watt bulb or a 100 watt bulb. And that is just a measure of the heat and light output of the bulb. And it's very easy to calculate the amount of heat or light being dissipated in a circuit by multiplying the current and voltage in that part of the circuit together. So I put the power equation in a triangle again for you. So if we wanted, here's the triangle, if we wanted P, we'd put our finger on P, and P equals E multiplied by I. If we wanted E, we'd put our finger on E, and E equals P divided by I. If we wanted I, put our finger on I equals P divided by E. We're going to do a calculation for power. We are told that the voltage is 240 volts. We are told the current is 2 amperes. We know that P equals E times I, so P equals 240 volts multiplied by 2 amperes. 240 volts multiplied by 2 amperes gives us 480 watts. The unit of power is the watt. Well, that's about as far as we're going to go in this tutorial into Ohm's law and current, voltage and resistance and power. I'd like you to revise this tutorial, and don't forget that if you obtain these tutorials through the Radio and Electronics School, you'll be sent all of these videos on DVD and to play on your computer in high resolution. But the important thing is you will have self-testing software drills to test you on similar types of questions mentioned in the tutorial based on your foundation assessment. The software drills are most valuable to you when you're doing this course. Okay, I'll see you back in the next tutorial. Cheers for now. Good luck with your course. This is Ron, VK2DQ.